Hello everyone, in this video we are going to make a LED flip-flop flasher. So we want to start with the schematic or diagram of the circuit. Then we will design the PCB board in EasyEDA software, and finally after we design that in the software we will make the PCB board at lab. So we want to actually show the whole process that usually you need to take to get and make your PCB board. Okay, so as you could see here, we have here one LED flasher. So the LED flasher has use two transistor, 2N222. They are NPN transistor. We have few resistor and capacitor, and also we use two LED. So first we start with the schematic and the diagram of the circuit, and then we move and design that in the EasyEDA software. So let's start that and see how we could design the schematic and have that in EasyEDA software. So in the first step, you should have your circuit schematic or the circuit diagram. So any PCB board actually start with the schematic or the circuit diagram. So for this example, we have the diagram of the LED flasher. So as you could see, we have two transistors. They are NPN 2N222. We have two LED here. We have two 100 ohm, also two 10K resistor and two capacitor 100 macro, and also this one is the connector which we give here the DC voltage of the 9 volt. So usually if you want to make the PCB board of the circuit or any other circuit, so you need to first implement this circuit on the breadboard and make sure your circuit is right, the diagram or schematic that you have is right, and whenever you make sure that's right, you actually move to the next step, which the next step is to design a PCB board in your software. For our case, that will be designed in the EasyEDA. So for prototyping the circuit or diagram, usually the tools that we have is the breadboard. So here I show you the breadboard and how you could use the breadboard. So this is a breadboard that usually we use to prototyping the diagram or any schematic. So as you could see here on the breadboard, usually there is some holes. So these holes that you see as a BCD, which is these holes that you see here to here, they are connected to each other. Same thing for this side. Whatever you see in one row, which is 1, 2, 3, 4, 5, they are actually connected to each other. So that means here to here connected, here to here connected. But there is no connection between these two places. Same thing here. Usually we use this side for the power. So for this side that you see, it's labeled as a positive, negative, negative. Whatever you have in one row, all of them is connected to each other. Same for positive and same for negative. So that means whenever you want to implement or prototype your diagrams, so you don't need soldering and you don't need anything. If you want to connect 2 points, you just need to put that 2 wires inside these one row. So that means you connect them. Okay. For our case, we are going to implement the diagram, the LED flasher diagram in this breadboard. Make sure circuit and diagram is right, then we will move to design that in EasyEDA. This is what we did. So we actually implement the same diagram that you saw in the beginning of the section, and as you could see, the diagram, the schematic works. We make sure everything is fine, the design is fine, and then we are going to move to the next step, which is design the diagram in PCB design software. So we are going to implement the same diagram that you saw with EasyEDA. So let's move to the next step and design the diagram in EasyEDA software. Okay, as a next step, so as you see in the previous section, we have these circuit diagram, and we want to design this circuit diagram in the EasyEDA and also design its printed circuit board, then make that pre-printed circuit board. So this is exactly the same circuit that we implement in Breadboard, and we make sure the circuit that you have, your design circuit, works. You already prototyped that in the Breadboard, so now we are going to move to design that in our software, which is EasyEDA. Okay, so in the EasyEDA, so the first things you need to do, you need to make the project. I already log in, so you need to log in first. So then you need to go to the new, and we are looking for new project. You could give any name. So here I'm going to name that lab 5. So then we just need to save this, which is I save it. So then as you could see here, it's made the folder, and here I have the place which is the schematic of the project that I'm going to have here. So go to the library and see what we need to put here. So again, back to your diagram. So we need 4 resistor, we need 2 transistor, 2N222, and 2 LED and 1 connector. So let's bring everything actually inside in our design. So start with the R. So we need actually have 4 R. So I put 1 R here. I double click on that, then check the footprint and make sure this is the right things, that this is what we want. So see, this is actually these make 2 holes, and this is exactly what I want. Okay, so then I actually add 1, 2, 3 more. So totally I need 4. So go to the capacitor. I need actually 2. So this is one of them. Again, click on this, click on the footprint, and make sure this is for one side PCB board, which is make a hole. So that's right. So then I click again here and make this is the wrong one. I need to actually have exactly the same, which is this one. Okay, so again, if you want to make sure this is right, just click on the footprint and make sure this is the right component that you want. So we need LED, so go and find LED. The LED is here. I put one of them first, so then check its footprint and make sure this is exactly what we want. So see, this side is the negative. Yes, that is actually what I need. So go and put the second one. Okay, so what else we need? We need a connector. So here we have the connector. I actually click this, put this here. So what else we need? We need a transistor. So if you take a look, at least here I couldn't see any transistor here. So that's what you need to go to the library. You go to the library, you just search for 2N222. So then enter, it's actually bring the list of what we have with that name. So we are looking for NPN transistor 2N222. It's actually the generic NPN BGT transistor. This is its sample. This is exactly what we want, and you see it's actually silk on the top of the PCB board, which is this is what exactly what I want. So you just need to put the place. So I need two of them. Put one here, another one here. Then I should be good. Okay. So let's do a little zoom that. So back to your diagram and see exactly what you want to do. I'm exactly to follow the same diagram or schematic that I have here. Okay. So definitely these transistors should be somehow flip horizontal based off the schematic that we have. So this transistor goes here. So these LEDs should be rotated. If you click on that and push the R in your keyboard, it's actually rotate that. So this is what we have. That's right. I put that here. So again, if you forget, you see we have R, then we have 100 ohm. Okay. So that means I need one of them. So it's better to match with exactly what we have here. So which is we have R1. So because this is 2, I actually use these R2 in this side. Okay, again, I click on that, just rotate it and put it here. So just make sure it is in the same row that we have. So then, yeah, do the similar thing for this. This is Q1. It is better to click this R1 here. So these two should be rotated. This one should be rotated. I actually put these here. So this is C1, Q1. So let's to see what we have as a C1. C1 is here. Should be positive on the left side. So which is right. So I put these like this. And the same thing for the other. So again, back to here, the positive is on the right side. So that means you need to rotate this. Okay, I rotate that and put that here. Again, back to C. Okay, so you have these R3 and R4. So this should be comes here and exactly parallel with these R2. So this one should be rotated, which is I rotate that and put it here. So you could rotate the connector too, which is I did. So then again, back to your diagram and see what we should have. So the C is here, R is here. Probably we just move these a little down. So again, back here is R, and it should be fine. Okay. So we put everything that we need. So the next step is wiring tools. So here you have the wiring tools. You click on that and exactly follow what you have in that diagram. So here is the one of them. So go to the next. So this then connected to here. Just make sure you have this dot, which is somehow confirm that you made the connection. So the same thing here, you actually put these here, then go to the other side and connect to this, the connector positive side. So again, this should be connect to the LED, so that's right. Then this should be connect to this side. Again, make sure you actually have that dot. So same thing for this, it's to actually connect here. So it puts the dot, it is good. So back here, again, do the same thing, it's actually at the dot. So this looks should be move a little this side. So again back here and connect these two. We already did this, so back here it should be connect to this one. That's good. Back here you need to do the same thing for this one, which is connected. So again, if you anytime you forgot, you could actually back to the circuit and see what we have. So see the base connected to the 10K. So let's do that. So these actually connected to, yeah, the first thing is maybe that's better to put these as a right value. If you click on that, this should be 100 ohm. So which I changed that to 100. This is also 100 ohm. So which I changed that to 100. So this should be 10K. We need to add 10 here, okay? So that's 10K. So this is also 10K. So it should be 100 macro. This should be the same thing, 100. We just change that. Anything else that we need to change? No, the all is right. So back here again. So see the base goes and connect to the R4. That means the resistor that you have in the further of these transistors. So this base, which is should be wire up and should goes and connect to these R that you have, okay? So similar thing, this one should be goes and connect to that one. So you actually go and even if you want to be better, you could actually move a little up, then move back here and connect these to the here, okay? So again back here its base goes to the these R and its base to the other R that we have, okay? So then back to the DCs, one side of this should be the collector and another should be connected to these base. So that means again you need the wire and this should be connected to here and the other side should be connected to these line that we have, which is the base of the other transistor. See the base of the other, same thing here. This should be connected positive here and the next connect to the other side. So see, just again you just push the one connection here and the other connection should be this one. So see, I should be connect this, okay? So again just double check which is right. So you put that 2, it comes there, you have the C, that's right, and the C connect one side, other side in it. This is 10K 10K, this is 100 100, and you have the transistors. Yes, you could actually switch between these two and make sure whatever you have is exactly the same with the diagram that we had, okay? So yeah, it looks just I switch between these two, just make sure everything is right. That's right, that's right. It comes to the base, that's right. It goes here and comes to the base. Just be careful, there is no connection between these two. So see, it comes to the base and this comes to the this base, and here there is no connection between them, okay? And the DC connector will be connected to the 9-volt DC. So whenever you did that, just save it. It's going to save that. It's successfully saved. So here I have the schematic. So the next step is go and convert that to the PCB board. So I'm just push that button. So it's actually get the PCB. For now, I just cancel the size. Later, I could adjust that, okay? So as you could see here, so you have your outline. So yeah, see, this is what we don't want. So let's see, yeah, probably the connector that we selected is the wrong. So I'm back here. So yeah, I select the potentiometer, not the connector. So I delete that, back to the here. So comes here to the connector that we have. So where is the connector? Connector is here. Yeah, these are the connectors. Yeah, I need to select this. So actually select the wrong thing, but it doesn't matter. So here you could again take a look to the footprint. Yep, this is what I want to do. So it is right. I have no problem with that. Just rotate it and make a connection, which is I connect this to this section and also connect this to the other section. Okay, so even if you want to actually have, yeah, maybe that's better to see. Yeah, this is one. How about this? Yeah, this is the second. Okay, so that's good. So we actually back to the project again, because you made the change. You actually put as a save. So then back convert to the PCB board. It's actually convert to the DC board. This time it's good. Actually, this is the connector that we have, H1. So again, I cancel that, and for now, you could do this. So here we have one option in the view, zoom, you could say fit on the windows, which is it's fit to your windows. So then, as you could see here, I'm going to make these outline a little bigger. Yeah, probably based on what you need. So for now, I'm going to just expand that a little bit. That should be fit for what we have, okay? And also this side should be a little bigger. I actually expand from this side too. So then you could actually select everything and use the arrow keys on your keyboard and move that up and down, okay? Because it is web-based, usually there is a delay, but it's not bad, you could do that. So again, you put whatever you have inside your outline that you have. So it needs to go a little the other side. Okay, so it looks okay. So even you could actually give them more room, which is make our work more easier, okay? So even from this side, I prefer to have or extend that a little bit. So again, as I already mentioned, it is somehow the art, so that's up to you and how you want to design that, okay? So almost we have everything here. So even if you want to have more room, you could again expand from the one side. So for now, it's okay. So as you could see here, there is too many lines here. Usually that's better to put in the same order that you have on your diagram, okay? So see, I have in the one side here and Q1, Q2. I try to put the element in the same location with my diagram. And again, this is up to you. It's usually, if you do that, you have less cross tracks here because it's a problem later on. You couldn't actually cross two track, okay? So let's do that. As I mentioned, the rest of that is the art depend on the use. So this is what I'm doing, and yours design shouldn't be exactly same as what I have here, okay? So just rotate that and find the best position for that. That's right. This Q2 should be goes to this side. The Q1 should be comes to here. The LED one is here. The R1 should be on the top. So the R2 is right. These LED2 should comes here, and the R3 is here. Should be rotated probably. Yeah. And R4 should be here. Maybe need a rotation. Yeah, that's right. So this is your LED, and see what we have. Yeah, probably you could rotate this one too. It give you a better lines. Okay, so how about this rotation of the R1? Yeah, maybe the first one was good. Okay, so yeah, you could rotate that one more. Yeah, it's okay. Yeah, maybe you could rotate this one too. So how about the rotation of R2? Yeah, the best one is what I have. So even you could check what you have here based off the diagram. That's better to have a general idea about your circuit. So see, one R2, all these connected to each other, connected to the H1, which is I have the same thing. Somehow I keep these in my mind, and whenever I have that wires, I just want to double check and see everything is fine. Okay, because sometimes you have a bad connection and you see they messed up here. So that's good to actually have the general idea about the circuit. So C1, C2, so this should be come somewhere here. This comes a little down. So this C goes here and this one comes here. Okay. So about Q1, Q2, rotate and see what we should get if we rotate that. So yeah, it looks this one is better one. You actually cross list each other. So how about this? Yeah, this one looks actually better. I'll see there is actually less crossing track. So even this C2, you just rotate and see what it gives to. Yeah, this one is not bad too. So I keep in this shape. So this C1 is right. So as you could see, I don't have too many crossing tracks. So there is just one here. That's fine. We could actually figure out to see if I rotate this, what should be happen here. Yeah, this actually also nicer. How about this? Put the R2 on the top. Yeah, put these a little down. This goes a little to center, and it comes actually a little down. Yeah, it looks fine. Yeah, again, up to you and up to your design. As I mentioned, it is the art, right? So some people is good in these kind of the things, some people is not good, but it doesn't matter. So the important thing is you do your best. So yeah, see, right now it's not bad. I just extend that a little bit, extend this too. To see what we have here, it's connect to here, which is probably I don't like that. So let I move that around and see what I will get. This one, that was what we had original. So I have one here, which is okay. So also, how about this? Could we rotate this? Yeah, this one is not bad. So yeah, that's good. Just try to make that. That means keep that symmetry that you have here. So these two is here, should go a little up, almost here. So these two is almost good. This should becomes a little down. Okay, so not bad. So we could actually have this. So yeah, whenever you satisfy your design, then definitely you could come here and say go to the bottom line and here click on the track and make tracks that you have. So this could be the one track. So other things you need to be careful whenever you have a track, click on track and you could adjust your track. Okay, so here let us see, you need to select the units. So you click on the outline here, you select any units that you are comfortable. So I'm comfortable with millimeter, so I click on the millimeter, every unit change to the millimeter. So then I want to click on the track and adjust the width of the track. So let's put that on 1.5 millimeter. So which should be fine for, because we are going to make this, we should have enough width whenever you are making this PCB board. Okay, let's put on 1.5 for the width of these track. Okay, so back to our business, which is the wiring. It's connect to here, so then should be connect to this one. So see, because I have another one, I go up for this, comes here, and then connect these two here. Okay, so see, right now whenever I do this, I don't need to cross two track. Okay, so this one is good, so this one is connected to this, so we are good here. So here should be fine. So this one should be also, yeah, so you could go from anywhere. And so just make sure you have the right thing here. So I just put this back. So again, we click on this. So same thing for the other pin. So let's see what we have here. So yeah, this it shows it's not connected. So let's redo this. Okay. So even probably I need to rotate this. Yeah, right now it's better. Okay. So go to the wiring. It's actually connect to this. So right now I have the connection. So again, back here, click on this and click on this. So again, it's not get that. You just need to make it to finish this side. So we have the connection there. So let's have this one. Yeah, probably there is no enough room. You need to change that somehow. That's able to give enough room to the track. So even whenever you want to do that, you could rotate that. Okay. So yeah, for connecting this, you could just make a connection here. You connect that. Yeah, so you could, yeah, let's do one thing. So whenever you put 1.5, so as you could see, it's don't give you enough room, right? Maybe the 1.5 is a little, we need to decrease that, okay? Because for some part of that, it's not give that space. So I just click on one of these and change that probably to 1.1. Okay, so right now it is smaller and probably give the enough room to connect that. Okay, so see, it's actually give enough. You could actually change whenever it's actually don't give enough space. Okay, so you could actually have one a little smaller that get enough room to have your connection. So here to here you connect that. So here to, yeah, maybe comes here, then connect to that, you have that connection. So here, come here and connect to this, you have the connection. So here you could go like this, and we shouldn't be problem for connecting this one to this. And see, you just need to sync. So here we have two, which is if you put these two here, and the next one should be go from somewhere else. Okay, and see which one could be more easier to connect. Okay, so you could actually, for connecting this to this, you could go, yeah, I need to do this first. So you do this. So here is not good. So see, there is a very small space between these two, which is I'm going to delete that. So maybe we do something like this. Yeah, we have to do put these here. So what I'm going to do, I'm going to change this one. Okay, because I don't want to have any wire too much close to each other. So for this, maybe there is a better way to go out. So see here, you could comes here, go here, comes here, and you go from here, which is even you could, you see, if you don't have enough space, definitely you couldn't pass through that. Okay, so that also that means let's do one thing else. So first let's get rid of this. So let's see what we could do here. So for coming here, so even if you see, if I want to cross these line, it's actually don't let me to do that. So even here, I don't have anywhere to go. Here, I don't have anywhere to go. So definitely I need to make some changes here. So let's do this. So for connecting this to this, so let's first do one thing. So the yeah, probably you could, how about rotate this? Yeah, if I rotate this, yeah, probably it solved the problem. And also take this a little back. And could I go to the other side? So again, you could connect this to this, which is there is no problem. So you could get rid of this first. So also here, you could bring this somewhere. Yeah, you could actually see move around. So it shouldn't be a big deal here to change whatever you have. Okay, so I could do this. I keep these here, I rotate that. So then I could actually go outside. Okay, so I could comes from this one. So see, this could be solve the problem. So I comes here, I go here, I comes here. So then I go back here. So see, I could do this, then comes here, then comes to here. So then connect that to this. Okay. So which is still I need the connection here that's not connected. So yeah, probably we need to, the reason I put 1.5, So it's actually make definitely the putting the tracks will be more tough because you have the less space. So if you have any problem with that, you could actually change its size. Okay, at least less than 1.5 that I selected. So see, whenever it's 1.5, it's actually give somehow the hard time to the connection, but we solved the problem. Okay, so the rest should be easy. So you connect this to this. So also you need a connection here to here. So, and what else? So what we have is this one comes to here, and yeah, see, it's actually again didn't get that because it is somehow too big. So, but we have to do that. We don't have the printer. We are doing with the simple way to make these PCB board. So we have to make the track as, yeah, this time I think it's get it. Okay. Yep, it's get it. So we made this. Yeah, the only connection left is whatever you have here. So you bring this here and you could, yeah, let's do this. Yeah, I need to get rid of this. Again, we select this one and comes here. Then go and connect to this, okay? So we remade it, so it's actually connected each section that we have. So again, if you need more room, you could actually expand your outline that you have. So here I just double check everything. So see, as I mentioned, you should have these in your mind, okay? So even if you are done, it's better to check everything with the diagram and make sure whatever you have is the right thing. So which I'm going to do that. So see, we have our two here. So it is all these are connected to the VCC. So see, this is connected one side to VCC, this is connected to VCC, this is VCC, and this is H1. So you could actually have a general check, okay? So the other things you need to put, you could put your name, and also usually each PCB board has some holes to attach to the anywhere that you want. So here I put these holes here. If you are interested to have some name on it, so you put this here. So if you click, you just type your own name, okay? I'm here typing my YouTube channel. So depending on the room that you have, should be fine. So if you need to have more room, you could actually expand from the one side that you have, okay? So don't forget to save it. So you save it, it's going to save, you got your schematic and the schematic, and you have your circuit, okay? So you have these LEDs, U2 and 2Q, that's what you have, okay? So again, as I mentioned before, it is somehow the art, okay? So yours definitely shouldn't be similar with what I have here, okay? So then the last step is just explore that as a PDF file. So you explore that as a PDF. So we want to separate it layers, so you could get rid of the others that we don't need. And the last step is just export that as a PDF and black and white. Yeah, everything is fine. So you actually download that on any folder that you want. So whenever you are done, you just go to check that folder. So then you will have the circuit, okay? So if you check on the bottom layer, you couldn't see that, but that is here. Okay, this is what we need for making our PCB board in the lab. Okay, this is one side, and if I could click the silk layer, you see also the silk layer that you have. Okay, so you should have both sides, and we will use that for making our PCB board in next step. In the next step, we are using these two, and we will show how you could make the PCB board at lab. Thank you.